Now that we've looked at how to find an x-intercept or how to solve a quadratic equation by using square roots, now we want to look at how to solve them by factoring. So I'm going to focus I know there's a lot going on this page up here, but I'm going to ask you to focus up here. If I told you 7 times a was 0 and then I asked you to find a, all of you would most likely say, well, a is 0. That's a pretty easy equation to solve. Same with the second one. If 2 times b equals 0, what does b have to be? Well, again, b has to be 0. Although sometimes I see some of you want to say there's no solution because you don't like the concept of a letter being equal to 0. But once you kind of get over that hurdle, again, like I said, it's a pretty basic equation to solve. Well, what if I had 5 times 3 minus c equals 0? Could I solve for c? Well, when I had two things multiplying in the first and second equation to be 0, I knew that the variable, since I already knew 7 was not 0, I knew that that variable had to be 0. Same thing here. Because I knew 2 was not 0, I knew that b had to be 0. Well, what do I have here? It's written a little bit differently, but I still have two things multiplying to be 0. Since the 5 cannot be 0, that tells me that the 3 minus c has to be 0. Well, in order for that to be a true statement, I can see that c would have to be 3. If I take that same concept and pull it just a little bit further, if I had two binomials multiplying together to give me 0, in order for that statement to become true, I know that one of my two binomials would have to be 0. So I know that either x minus 4 would have to be 0 or x plus 7 would have to be 0. I could solve both of those equations to figure out my possible x values to make this a true statement. But one of them has to be 0. The only way two things are going to multiply to be 0 is if one of those two things is 0. So if x was 4, this piece of this binomial would become 0, making 0 times 11. Well, 0 times 11 is 0. If x was negative 7, and I solved this piece, that would give me negative 11 times 0. Well, negative 11 times 0 would be 0 because I'm following my order of operations. That is what we call, all of these are examples of the zero product property. The zero product property tells us that if two things multiply to be 0, one or both, but at least one of those two things has to be 0. We're going to use that concept along with factoring. So notice I put in the square roots that was in the last video. So now with factoring, when we use factoring to solve a quadratic equation, this will probably be close to your number one method for solving, especially as you start progressing through your math career. We will kind of essentially use factoring whenever you can factor it. And if you think about all those different ways we learned how to factor with a GCF. We learned how to factor with a couple different special formulas, the perfect square minus perfect square, as well as the perfect cube plus or minus the perfect cube. We also learned how to factor with the factor sum tables, with grouping and grouping. So a lot of different ways to factor. If we are going to be able to factor, before we can determine if an equation is factorable or not, we have to put the equation in standard form. So that ax squared plus bx plus c, and we want it to be equal to 0. The constants, any constants we have, come over and combine with that c, that first constant. Then we will factor and use the zero product property. So let's look at what that looks like. And before I kind of move forward with the examples, I do want to point out that this is called solving quadratics by factoring, but there is an example on how to solve a cube minus a cube, so a cube equation with factoring, as well as how to solve a degree 4 equation with factoring. So number one, I have to find the x-intercepts. So in order to find the x-intercepts of this equation, the first thing I'm going to do is I'm going to plug in 0 for y, because I know if I am on the x-axis, I am up or down 0, my y is 0. So I will have x squared plus 7x minus 18 equals 0. Now in order to solve this, I first asked myself, could I use square roots? But because I have a linear term, I cannot use square roots. So next thing I'm going to ask myself is this factorable? Well, I see I have a trinomial with a coefficient of 1, so I'm going to use a factor sum table. I'm going to do factors of negative 18 with a sum of 7. Some of you will probably find that you can do this in your head without making the table. So if I want to find two things that multiply to be negative 18 and add to be positive 7, I would say 9 and negative 2. So this is going to become x plus 9, x minus 2 equals 0. Now that it's factored according to the zero product property, one of these two factors has to be 0. Either the x plus 9 has to be 0 or the x minus 2 has to be 0. Well, if I subtract 9 from both sides, I get x equals negative 9 or x equals 2. So those are going to be my two answers. If I wanted to, I could plug them back in to check. Why am I getting two answers? Well, if you think about what a quadratic equation looks like, it takes the shape of a parabola. So it should make sense to you that I would have two x-intercepts because I should cross the x-axis twice. If I look at example 2, first thing I'm going to do is I'm going to get it in standard form because I already know I can't use square roots because I have a quadratic term, yes, I have a constant term, yes, but the big thing, why can I not use square roots? Because this linear term is appearing, and I cannot use square roots if I have a linear term. So to get it in standard form, I'm going to add 4x and subtract 6. I would prefer to not have my quadratic term negative. It gets weird to factor when it's negative. So I will move everything over to the left, and it will then be equal to 0. I notice I have a GCF of 2, so I'll take that out, giving me x squared plus 2x minus 3 equals 0. As you may remember from our previous unit, even after I take a GCF out, oftentimes I can factor more. This is one of those cases because if I'm trying to come up with two numbers that multiply to be negative 3 and add to be 2, I know that in order to get negative 3 and add to be positive 2, I can do 3 and negative 1. So this is going to become 2 times x plus 3x minus 1 equals 0. I now have three things multiplying together to be 0. So either 2 equals 0. Well, I don't have to solve that because that'll never happen. X plus 3 equals 0. Or x minus 1 equals 0. Well, if x plus 3 equals 0, that would mean that x can be negative 3. And if x minus 1 equals 0, that would mean that x would be 1. So those are going to be my two solutions to this equation, aka my two x-intercepts. Looking at the last three equations, the last three examples. Example 3, I notice because there is a linear term, I will not be able to use square roots. So I'm going to move this linear term over to this side by subtracting it off. Once I subtract it off, I'm going to have 16x squared minus 8x equals 0. I check for a GCF. I see they're both divisible by 8x. So I'm going to pull that out, leaving me with 2x minus 1 equals 0. Again, I have two things being multiplied here. So either 8x equals 0 or 2x minus 1 equals 0. Solving this first one by dividing both sides by 8, I get x equals 0. Or I can solve this one by first adding 1 to both sides and then dividing by 2, giving me x equals 0 or x equals 1/2. Looking at example 4, as I stated before, there are some cubic and there is a cubic function as well as a degree 4 function. So looking at my cubic function, I notice that it's already equal to 0. It's in standard form for a cubic function. So the next thing I'm going to ask is, can I factor this? And I can. I know that my a is x and my b is 2, since 2 cubed is 8. And this factors to be x minus 2 times x squared plus 2x plus 4 equals 0. Well, that means that one of these two pieces has to be 0. So either x minus 2 has to be 0 or x squared plus 2x plus 4 equals 0. Well, this first one is easy to solve. I just get x equals 2. Or when I look at this piece and I try to factor it, I see I cannot come up with anything that multiplies to be 4 and adds to be 2. So I see this is not factorable. So for the time being, I'm going to go ahead and say I can't solve this piece. We will re-look at this exact same example in the next video, and I will show you that there is something you can do with this. But for the time being, I'm going to go ahead and say I only get the one solution of x equals 2. So I'm going to leave that to kind of be continued, so to speak. And then looking at example 5, it's our last example. If you can hang in for just another minute or two longer. I have x to the fourth minus 81 equals 0. I know that that's factorable. I know that that factors because I get an a of x squared and a b of 9 squared, or I guess an a of x squared and a b of 9. I'm going to leave that square off. So this is going to factor to be a plus b times a minus b equals 0. I can factor this piece further because this is still perfect square minus perfect square. This has an a value of x and a b value of 3, giving me x squared plus 9 times x plus 3 times x minus 3 equals 0. Well, any of these three pieces can be 0. X squared plus 9 can be 0. X plus 3 can be 0. Or x minus 3 can be 0. I can solve these back to fairly quickly. X is either negative 3 or x is positive 3. This piece here, when I go to solve this, I realize that it's a quadratic equation, but it does not have a linear term, so I'm going to use square roots on this. When I do, I end up with x squared equals negative 9. So x equals plus or minus the square root of negative 9. Well, I've already learned what to do with that. That's going to give me an imaginary number. So I get x equals plus or minus 3i. And notice that I get 4 solutions, negative 3, positive 3, 3i and negative 3i. So notice I get 4 solutions and I have degree 4. It is always going to happen that way. Our degree is going to tell us how many solutions we should get. However, it's not always going to be real solutions. It's going to be our number of total solutions, both real and imaginary. So I apologize that this video is so long, but there's a lot of stuff in it. So big thing to summarize is when I'm solving quadratics, if I have a linear term, I use square roots. Don't forget the plus or minus. If my equation is factorable, get it in standard form first. Then use all the different methods you've learned for factoring, whether that be GCF, whether it be GCF with something else, whether it be perfect square minus perfect square, or perfect cube minus perfect cube, or whether it be factor sum table, factoring by grouping, any of those strategies that we've learned in previous videos.